Hi, I'm Eghbal Rahimikia, and I'm an assistant professor in finance at University of Manchester, Alliance Manchester Business School. Today, we are going to talk about realized volatility forecasting, machine learning via financial word embedding. We start with financial textual analysis. We introduce fintechs. We move to volatility forecasting as an application. We compare the forecasting performance of different models. Later, we move to ensemble models, and the most important part we are going to focus on that is explainable AI. What is the point? What is the goal of financial textual analysis, or in general, textual analysis or NLP? Transforming financial textual data to numerical data. So when we have numbers, we can analyze it using the models we already have. But it's not an easy task because textual data is quite high dimensional. So there are different approaches from last decades in the literature, from one-hot encoding to something more advanced like word embedding. And after that, we have the recently introduced models like GPT model. But in finance, most of the research is focusing on dictionary-based, and most specifically, McDonald dictionary. So McDonald dictionary is just classifying the tokens or words to negative sentiment, positive, mostly negative sentiments, and positive sentiment and other sentiments. And the most important feature of this dictionary, and all dictionaries in general, is based on personal judgment. This dictionary is based on financial statements, not the other textual corpus like news or transcripts or the other ones. So it's very specific, their usage. And there is no link between output and input. So if we are doing written forecasting, we are using the same sentiments. If we are using volatility forecasting, it's exactly the same. But recent papers and research is mostly focusing to expand it and bringing this linking between output and textual data inside of the model. But the point here is that most of them, they are ignoring the non-linearity in the textual data, which is quite important in textual analysis. Here, first we introduce fintechs based on Dow Jones Newswire textual database, which is around, like, we are using 15 years of all news in the market for developing a word embedding for finance, accounting, business, and management. After that, as a case, we are applying this fintechs inside, or we are incorporating this word embedding inside of the simple neural network machine learning models for volatility forecasting. And most importantly, we are applying explainable AI to understand how it's actually working and detecting the important context for realized volatility forecasting in the textual data. So word embedding is quite simple. The definition, suppose that we have king, queen, prince, man, woman, and child as unique tokens or words inside of our corpus. So we have different dimensions, royalty, age. So usually we have more than this, 300 for 500. For our case, we are fixing it as 300. As you can see, for king, the royalty is the maximum, near 1, but for man is the lowest one. So the point here is that how we can reach these 300 weights for each token. There are different simple models in the like the literature, like word-to-vec, negative sampling, glove, and most of them are focusing that when two tokens are happening near to each other in our corpus, usually they share the same meaning. It's quite simple, the structure, but it works very well. So here, we are developing our own financial word embedding, which is available online on fintechs.ai website and covering all news in the market. But we know this database is mostly focusing on finance and economics. It's near 15 years of data. The end year is 2015. And actually it covers around 3 million unique tokens inside. And we are training it using different algorithms and models we have in the market, word-to-vec, and fast text as algorithms, and SIBO and skipgram as models. The dimension is 300. The dimension is exactly the same thing we have here. And as you can see, if we consider the size of the corpus we are using, Google model has the largest corpus, near 100 billion words. After that, we have Facebook, Wikinews, and after that, ours is the smallest one. When we apply some general benchmarks like the analogies developed by Google, this is for comparing word embedding in the language level. We can ask some questions from the word embedding, like city to a state, like the question like Los Angeles to California is like New York too. The model should be able to answer this question. For each row, we have different like bunch of questions like 500, 300, and you see the average accuracy here and the overall average. As you can see, Wikinews is clearly winning here with 91% average accuracy. And after that, we have Google. Fintechs is fair, around 53, 62 is not very bad, but it's not reaching there. Second group of benchmarks, which is mostly focusing on the relatedness and similarity, is showing that Google in this case is winning. So it depends on the benchmark we are applying. They have different approaches. Here, they focus on some analogies in finance, like so let's ask some questions. Bullish to bearish is like rise to. Google's answer is rises. We can use rises, but fintechs is reporting fall. Let's make it more complicated. Microsoft to MSF is like Amazon to Apple, HMV, Amazon, AMZN, which is the ticker of the Amazon. So this is right too. Creditor to lend is like debtor to, and you can see fintechs is reporting the right answer. You can see here that fintechs or this word embedding we develop has more understanding about financial accounting, business, and management terminologies. Another example is based on dimension direction of those 300, like the dimensions to 2 for presentation here. A model works well when it's classifying all the company names together based on the industry they are working. So as you can see, fintech is putting Walmart and Tesco together, HSBC, Barclays, Citi, and UBS together, and IBM, Adobe, Microsoft, and Google together. But Wikinews and Google model, they are mixing them. So it means they don't have that much understanding about the industry. These companies, they are working based on the names. But it's not enough. For the first time, we developed gold standard financial benchmark in language level. And again, like the first benchmark I showed, that we are asking 300 questions at each level. We developed this model based on by using Orbis data, Moody's Orbis data. So each one contains, we just covered the top companies in each section based on each country based on the market cap, and based on the permutation we make different analogies like ticker to city, Microsoft to the city the company is based in is like to like Apple too. So the model should be able to answer this question. As you can see here, in most of the cases, all cases actually, fintechs is winning in both. These are the differences between the models or algorithms they develop based on that. And the overall accuracy is 25%, but the overall accuracy of the Wikinews is around 0, and the overall accuracy of Google is around 3%. So fintechs in general is 300 times better than the developed model based from Facebook, and also around 8 times better than the word-to-vec developed model, word-to-vec from Google. So now we want to use it. It's not enough. It was in the language level, everything we were talking about. And now we want to use it inside of the simple, like the machine learning model for realized volatility forecasting, because we know one of the engines behind, the engine behind volatility is news. So actually we want to link real news like textual data to volatility forecasting here. So we are focusing on realized volatility forecasting. These are the information forecasting structure. 2000 days for out of sample, 1,600 for out of sample data days is daily forecasting. Training period is 2,000 days, and the out of sample data is exactly after 2015, the time we finished or the end date of the data we are developing the fintechs word embedding. And after that, we are focusing on 23 stocks, and we are discriminating between normal and high volatility days just for presenting data. This one is not, we are not using it inside of the model structure. And we are applying reality check for comparing each model against all popular hard family of models. So when it's higher, it means that the model is showing improvement compared to all of them, and this improvement is significant for all cases. For the number of stocks in average, we are analyzing among 23 stocks, and these are our loss functions. As you can see, these are like the 23 stocks. We are focusing on that. This is the simple machine learning model. We are focusing on that here. So as you can see, the pre-trained word embedding or the other word embeddings we have for comparison, we are importing here, is here. So it's for translating the textual data coming inside. And finally, we have convolutional neural networks. Quite simple, the structure, fully connected neural network, this kind of like dimension reduction. And after that is realized volatility of next day for all headlines coming in the previous day. So compared to the financial model, it's quite simple. It's just considering one-day news. So the structure, but those models, when we talk about that hard family of models, they are actually using 23 days before for forecasting the volatility in the next day. So this is very like a straightforward. This is the open structure of the model we are talking about. That inside of that, we have trigram, bigram, and unigram for processing the data. Here, we are not using the model. We are just having word cloud. We are focusing on two groups of the distinct news in the market, stock-related headlines and general hot news. So these ones, these like news are related because we have tagging system in Dow Jones Newswires. We can discriminate between stocks. So these stocks are related. The news coming for each stock, we are training one model and retrain it every few days. And these news are related to each one of them for each training. But here for general hot news is quite general news. And as I told you, it's for quite distinct information here. The first thing, this is for reality checks results. As I told you, when it's higher, it's better. Full out of sample period, normal volatility days, and high volatility days. As you can see, for most of the cases, fintechs is showing very good and high performance. And also the most improvement in performance is coming for high volatility days. So we can conclude that when we are talking, you can see high volatility days and the stock-related news together. Stock-related news are mostly the information related to the operations of company, like data, like maintain, like price target. You see, most of them, vice president, and they're mostly related to the like iPhone are related to the products and the process we have inside of each company. So in most cases, you see fintech is working well, and it's mostly related to the high volatility days, and it's improving those days using this news. And you can see the time series of improvement during time. And for high volatility days, in most of the cases, we are comparing each model against CHAR model, which is the best model we showed in one of the papers. You can refer to that one. And you can see when it's negative based on the definition, it means it's showing improvement in performance. And for most of the years until 2022 in out of sample data for Q-log, for mean square error in first column and Q-log for the second log column, is showing improvement for high volatility days. But for normal volatility days, it's not very, like the improvement is not very significant, again, except like during the COVID. So as also you can see the improvement during like from 2015 is gradually decreasing because finally it doesn't show any improvement. And actually we showed that it's mostly coming from the number of out of vocabulary we have during time is increasing for all the models, especially for high volatility, especially for during the COVID, we highlighted that one here, and we have sudden jump. And this shows that, okay, the model needs retraining because we just we finished training them up word embedding until 2015, actually is losing its performance during time. And when we move to general hot news, you see is the improvement first is moving to mostly normal volatility days, and most specifically mean square error. And also it's moving from fintech model to general word embeddings like Google and Wikinews. So we can see the same thing during time for general hot news. So for general hot news, as I told you, it's mostly focusing on the general information like politics, economy, like the Fed reports and like the meetings and other things, BBL, DOE, and jobless claims. And when we move to this one, more general stuff, the improvement is mostly focusing on normal volatility days, and this is quite important, this regime switching in the performance improvement. And actually those more general models have more information about more general textual data still compared to the fintechs. And finally, we are introducing some ensemble models. We are combining these models with previously introduced financial models in the market, like HARP, fully connected neural network, and order book LSTM, which are using like just financial information for volatility forecasting in a nonlinear approach from this paper. And as you can see, when we combine stock-related news with general hot news, it's kind of fine, it's improving performance, especially for full out of sample period. But when we're adding financial information, it's so significant, the improvement. These are reality checks result. And you can see it's improved, especially for normal volatility days and also high volatilities. This mixture improves the performance substantially. So it means we need both sources of information at the same time. Textual data and also financial data. When we mix them, usually it's beating most of the models we already have access to it of the popular group of our family of the models. But finally, we move to the explainable AI, which is quite important. Here, we are applying explainable AI on our model. So these last, termination, and against, these are the most repeated negative words in McDonald dictionary. And if I will be able to zoom here, yeah. So last, termination, and against we have here for each row. And also here we are using explainable AI results. So these are the times happening. Each point is showing one time. Last is the inside of the headlines for each ticker here, and when it's on the right hand side, it means it's pushing the volatility of the next day to higher values. When it's blue or left hand side, it's pushing down. First thing is that actually for 355 instances is pushing the volatility to higher values, not and for just 263 is pushing to the lower values. So we can tell, okay, loss depends on how we use each word, like loss inside of the sentence. It may convey negative or positive meaning in the text. And it causes like different impacts on volatility. And actually for each stock is different. For Apple, mostly is pushing to lower values, but for something like AMGN is pushing to higher values. And also the intensity is different. And for some cases, like MU is more widespread and more intense the usage of loss. This is for stock-related news. We have for hot general news results here too in the second column. For termination, we can see the same. For the against, we can see the same. And also we can see number of stocks is changing too. So here for termination, we have lower number of stocks because it may have two reasons. First, termination is not inside of the news for those stocks, or termination is inside, but model is not choosing termination as an important token inside of textual data, which is, again, dictionary-based approaches are not able to demonstrate something like this. After that, we try to, the most important part is that we try to find volatility movers in the market. What are the terminologies, unigram, bigram, that are moving the volatility, changing the volatility? This is the table for stock volatility news. We classify or are the results we obtain from our explainable by AI method in different classes. As you can see, the most repeated tokens or the structures are under analyst reports, neutral, cut to neutral, from neutral by, at overweight by. These are mostly happening in the analyst reports. After that, we have events, like earning call, off earning, earning season, earning preview. These are the structures, or 8K, 13F, the type of filing. After that, we have some verbs inside of our, like the textual data: sees, registers, assigns, source, acquires, back, declares. After that, we move to market, abbreviation, and the other ones, which contains a smaller number of like terminologies or structures. When we move to the next group, for volatility movers of the general hot news, person names comes on top: Trump, Joe Biden, Powell, Yellen, Fed people; Kramer, a personality like for like the presenter in TV. So it's quite interesting. See his name here. Meadows and the other people you see here. And also we have like some people, some places like US, Korea, Syria, China, Iran, Russia. Legal entities like ISM, DOE, OPEC, OMB, Health Organization. You see, we don't have like something like COVID in our structure, like the most repeated important volatility movers terminologies or structures. Yeah, because fintechs, board embedding stopped training in 2015, so it's not aware of this terminology. But still, you can see some of these terminologies. We have a CDC, Centers for Disease Control and Prevention, which is, we think, is mostly related to the COVID time. And we have some levels too, like under, above, or in dollar. It means like the amount: fall 12%, 20%. Verb, we have some verbs again: seen, sees, forecast. As you can see, most of the things we can see, it makes sense as volatility movers, and they are just generated by the model. So if you want to return forecasting, the number of like the structures, the language structures we have here is different. So we can change it to different things and apply the same structure. So the conclusion is that fintechs works actually very well for the financial, in the language model, based on a benchmark for financial terminologies or the relationships. But for the general purpose benchmark, it was not showing well results because it's based on just news, a specific type of textual data in market or in literature, not like widespread like the Word2Vec or Facebook model, which are using the Wikipedia and more general knowledge. And also we showed that in some ways it's showing some improvement in the volatility forecasting too. And also we showed that we can change this volatility with other things like return and the questions we have in asset pricing, and use the same model. And more specifically, we can use explainable AI to make it more transparent, to understand what are the volatility movers or the return movers in the market. Actually, we don't have most of the terminologies we can see here. They are not in the dictionary, but these models are able to extract this information from like the inside of the textual data we are feeding to the model. So we can change the textual data, we can change the output, and we can apply the same model for analyzing like the textual data and for different targets we are focusing on that. Thank you so much, and I hope it will be helpful for you. This paper will be helpful for you in future.